Hi, in this video we're going to look at how we go about reflecting shapes. The first video that we did on transformations was all about rotations, how we turn shapes in two-dimensional space. Now we're going to look at how we're going to reflect shapes. Now the word reflection is something that we use on a regular basis when we talk about seeing our reflection in a mirror or seeing our reflection in a piece of polished glass. And that mirror or that polished glass is basically acting as a line, the other side of which appears to be the image that we're seeing of ourselves. So any notion of reflection must have with it a mirror line. So here is a mirror line that's running down the middle of this diagram, and it's basically acting as a line of symmetry. What's on the right hand side of that line is being mirrored, reflected onto the left-hand side of the line. Now, if we think about these points, this point over here, this vertex at the point 3, 1, is 1, 2 units away from the mirror line. So its reflection is going to be 2 units away on the other side. This point up over here is 1, 2, 3 units away, and so its reflection is going to be 1, 2, 3 units away. Here it's 1, 2, 3, 4, 5, 6 units away, and we go 1, 2, 3, 4, 5, 6 units away. There we have the final vertex. And so we've got this shape being mirrored in this line. Now, the mirror lines that we get are not only vertical ones, they could also be horizontal ones. And so we just need to recap the work that you've done on lines, on straight lines, and just to remind you, what does the line y equals some number looks like? What does the line x equals some number looks like? Because they are one of the main types of reflection lines that you're going to use, mirror lines that we're going to use. Now, if you remember, the line y equals to some number is a line that is at right angles to the y-axis. It's the line where every point on this line has one thing in common, and that is that the y-coordinate of every point along this line is going to be the number 3. Likewise, if I take it down, then I'm going to get a horizontal line passing through, in this case, -5. Every point on that line has a y-coordinate of -5. And likewise with the x, this is the line where every coordinate on it has an x value of 2, so it's at right angles to the x-axis, and it passes through every point with an x coordinate of 2, or if I change that round, -5. So these are the mirror lines that we're going to use when it comes to doing our reflections. So let's look at some examples of this. So here we've got a whole host of shapes going from A through to P, and they ask the question, find the shape that is the reflection of the shape A. So there's the shape A in the x-axis. So the x-axis, this line along here, is going to be our mirror line. So if I go and take this bottom vertex over here, this bottom corner, this is 1, 2, 3, 4, 5 units away from the mirror line. So its reflection is going to be 5 units away, and that's going to be down over here. Likewise for this corner, it's going to be 5 units away, it's going to be down over here. So hopefully we can see that A is going to reflect onto M. What is the reflection of J in the line x equals 2? So here's the shape J. The line x equals 2 is a line where every coordinate, where x coordinate has a value of 2. So that's this line over here. So how far away is J from that line? So if we look at this top vertex over here, it is 1, 2, 3 units away. So I look for its reflection 1, 2, 3 units away. Once I've identified one point, it's normally quite simple to pick up the other points. This point is 1, 2, 3 units away. Its reflection is 1, 2, 3 units away. So there's that vertical line, that baseline that we have over here. So L must be the reflection of that line. the shape G in the line y equals 4. G is over here. The line y equals 4 is the line perpendicular to the y-axis where every y value of the coordinate points are 4. And that's going to be a line that runs along here like this. And we see this top point over here is 1 unit away from that line. So its reflection is going to be 1 unit away from that line. This one is 2 units away from the line, so its reflection is 2 units away. So hopefully we can see that G is going to reflect onto C. And if we mark this, we get them all right. If you want to go and practice these some more, you'll see the address up here. You can just go straight onto my iMaths and find this particular lesson. It's under shape, and you can practice some more of them if you want to. Let's take a look at the next situation. Now, they say to describe a reflection, you must always state what the mirror line is. So just as with rotations, we needed to have a center of rotation, an angle of rotation, a direction of rotation, 3 features there. For reflection, it's a little bit simpler. All we need is a line of reflection, and that's what we're trying to discover in this task over here. So, what is the line of reflection that maps shape P, there's shape P, onto shape M, that shape over there? If you think about a line of symmetry has to line somewhere in between those two. And if I think of this gap between this point over here and its corresponding point and point M, which is over there, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So halfway between those two will be over here, and that means we're talking about the y-axis. So the y-axis is the line of symmetry, or the mirror line for this. What mirror line maps F onto N? F is this one over here, N is this one down here. So let's take this point here, 1, 2, 3, 4, 5, 6, 7. Let's count that again. 1, 2, 3, 4, 5, 6. Sorry, 6, not 7. 6. So if I halve 6, it gives me 3. So halfway down would be 3 blocks away. So that's 1, 2, 3. So if I take my mirror line as being the line that runs along here like this, then I should be able to reflect F onto N. The line that runs like that means it's going to be the line y is equal to -2 because it's perpendicular to the y-axis and it passes through -2. Now we want to see E onto M. This one here, down onto that one there. Well, it's more or less identical, isn't it? E onto M. Once again, it's take this point 1, 2, 3, 4, 5, 6. So halfway through that is 1, 2, 3 down from there. So once again, it's going to be y equals -2. These questions here are randomly generated, so every time you refresh the page, you'll get a different set. So if you want to go and practice some of these, go for it. The address is up there, it's in the lesson. Now, here we've got some situations where they want to reflect the shape in different lines. And to do this, I'm going to do this on the OneNote. So let's see if we can plot these different reflections that we have here. So to begin with, they say reflect the shape A in the x-axis. So the x-axis, this line that runs along here, that is my line of symmetry. So this corner of the triangle A is 1 unit away from the line of the mirror line. So its reflection is going to be 1 unit away, so that's going to be down over there. This point over here is also 1 unit away from the mirror line, so its reflection will be 1 unit away. And finally, the third point is 1, 2, 3, 4 units away, so its reflection will be 1, 2, 3, 4 units away. and there I now have the vertices of that shape, and all I have to do is join them up. So this shape is symmetrical to the shape A, and we sometimes refer to this as A dash. Next, they want you to reflect shape B in the y-axis. So the y-axis is the vertical line that runs down the middle of the graph. That's going to be your line of symmetry. This first point of B that is closest to the y-axis is 1, 2, 3, 4 units away. So B, that point over there, is going to be reflected onto this point over here. The next point that I go to is 5 units away. 1, 2, 3, 4, 5 units away. So its reflection is going to be 5 units away. Now, once I've got that, I should be more or less good to go. I'll just pick up another point. This point down here is also 5 units away. So just follow along that line. And now my final 2 points, they're both 2 points away from, or 2 units away from the corners we've just drawn. And so now I can see here is my reflected shape, and I will call that B dash. Now they say reflect the shape C in the line x is equal to 2. Now the line x is equal to 2, let me get another color here, let's go take the cerise. X is equal to 2 is a line that runs down here like this. That goes through 2 on the x-axis. So now I just need to figure out how far away are my corners from this line. So if I start at the top right-hand corner over here, this point is 1, 2, 3 units away. So its reflection is going to be 1, 2, 3 units away. That side is 2 units long, so I know its reflection is going to be a further 2 points away. The shape doesn't change in size, so that line will be 2 units long, so I can just draw that point down there. This point here is also 3 units away from the mirror line, so it's going to be reflected onto that point there. And now all I need to do is get the last point, which is 1, 2, 3, 4 units away. So its reflection is going to be 1, 2, 3, 4 units away. There is my reflected version of the point C. And finally, we want to reflect the shape D in the line y is equal to minus 2. Let's get a light blue for that. D is in the line y is equal to minus 2. Right, my y is equal to minus 2 is the line that runs like this. That is y is equal to minus 2. So I need to reflect each point in that line. Now you'll see this point over here is already on the line, so it's not going to go anywhere. This point is 1 block away, so its reflection is going to be 1 block away. Likewise, this point is also 1 block away. This point is 1, 2, 3 away from the mirror line, so its reflection is going to be 1, 2, 3 away. Likewise, this point over here. This point is 1, 2 away, so its reflection is going to be 1, 2 away. And there I have my reflected shape, and that is the shape D dash. Hope that all makes sense. Now, the mirror lines won't only be vertical or horizontal. Sometimes they might be on a diagonal. They might be skewed. And that's why it is so important that we did that work on straight line graphs before this section, because we're going to use that information here. So just remind you of the lines that we've done. The line y equals x is the line that runs like that, diagonal at 45 degrees. Every point on this line, the x coordinate and the y coordinate are going to be the same. Likewise, if I've got the line going y is equal to minus x, well, there the y value is just the negative of the x value. So if the x value is 1, the y value is going to be minus 1. If the x value is 6, the y value is going to be minus 6. If the x value is minus 4, the y value is going to be minus 4, in other words, plus 4. So we can have these lines as our mirror lines as well. So let's see what happens with these shapes. Here they've asked us to reflect the line, the shape A, and the line y is equal to x. So if we just go and get that line drawn up, the line y equals x is a line that runs on the diagonal like this. So there is the line y is equal to x. Now, this is where you need to be careful. I want to reflect in this line, so I need to take the shortest distance to the reflection line. So I'm going to start out with the left-hand point of this diagram. And I'm going to say, right, from this left-hand point, I am 1 diagonal, 2 diagonals away from the mirror line. So its reflection will continue in that direction, 1, 2 away. So there is my extreme right-hand point. I'm now going to go to the extreme left-hand point on that baseline and see how far that is away from the mirror line. Now again, the shortest way to the mirror line is going to be along the diagonals. So I'm going to go 1, 2, 3, 4 diagonals. So its reflection will be 4 away from the mirror line. So 1, 2, 3, 4. And so that horizontal line is going to reflect down like that. Now, this top left-hand point is 1, 2, 3, 4, 5.5 away from the mirror line. So its reflection will be 5.5 on the other side of it. So there's the half, 1, 2, 3, 4, 5. And I've now got that vertical line. That's going to be this horizontal line over here. Now that we've started to see the way in which the shape is, the shape is appearing, it should be more straightforward from here onwards. So the top right-hand corner is 1, 2, 3, 4.5 away. So a half, 1, 2, 3, 4 away. It's going to be down over here. And that is that horizontal line we had. The top is going to be reflected along here. The last point is this one. It is 1, 2, 3.5 away. So a half, 1, 2, 3 away. There it is over there. I reflect it, draw my lines in, and there is the point or the shape, the reflection of A. If I folded down this red line, it would be a mirror line and the two shapes would fit one on top of each other. Likewise, if I want to get the line y is equal to minus x, the line y is equal to minus x is going in the opposite direction. So that's one that's going in this direction. The line y is equal to minus x runs like that. Let's extend the diagram out. See, that's not right. Now, I now want to see where this is reflected to. So I'm going to draw it in black. And I pick up any line, pick up any point on the shape. So I'm going to start at the top right-hand corner. From the mirror line, this is 1 diagonal, 2.5 diagonals away. So its reflection is going to be a half, 1, 2 away. It's going to be over here. Maybe it'll be a good idea to get rid of this red line. It's a mirror line that we don't need at this stage. So I'm just going to cut that. It's not there anymore. So there is my first point. The second point, this one over here, 1 away, is going to be 1, 2, 3 away, 3 diagonals away from the mirror line. So its reflection will be 1, 2, 3 away. There it is over there. So this horizontal line has now become a vertical line. If I drop down to the bottom left-hand corner, and this is going to be 1 diagonal, 2 diagonals, 3, 4, 5 and a half diagonals. So let me go a half, 1, 2, 3, 4, 5. There is this bottom left-hand corner being reflected up to there. And finally, my last point is this one on the bottom right-hand side. I go to the diagonal line or the mirror line. This is 1 diagonal, 2 diagonals, 3 diagonals, 4 and a half diagonals. So a half, 1, 2, 3, 4. There is the final vertex. So all I have to do now is to join these points up with straight lines. And there we have our reflected shape B' that's been reflected in the line y is equal to minus x. Well, I hope that all makes sense to you. What you need to do now is to go to the exercise that's linked with this and practice it. Thank you. Goodbye.